got a lot of talks on indoor location today. So the title of my talk is Technology Challenges and Opportunities in Indoor Location. Next slide. So this, this isn't necessarily a reference to QUALCOMM, too much detail on what QUALCOMM may be doing in indoor technology, but it's mainly just some of my perspective on some of the challenges that we'll be facing trying to get the same quality solutions we have outdoors into the indoor location. So contrary to what Martin said, the outdoor positioning problem is completely solved. So right there. Actually, a joke. There's still work to be done outdoors, but I think a lot of industry focus is turning towards pedestrian solutions, which offer certain challenges, and then particularly indoor, where things get extremely difficult. And I think there's a lot of technologies being suggested for indoors that have certainly a lot of merit, but I think again, same thing with what everybody's been saying today. Hybrid and multiple technologies is really going to be the answer to both having ubiquitous indoor location and also just high degrees of accuracy and availability. So outline at the top, we're going to talk about some of the drivers for indoor positioning, some focus on some of the key areas, indoor beacon technology, and I'm going to take a pretty broad view of what I mean by beacon, sensor technology, and then some hybrid positioning discussion as well as. So this is just sort of an overview of the types of drivers for indoor location. Some of the obvious ones people would think about in the old days is just indoor navigation. You're running through a mall trying to figure out how to get from current location to the Nordstrom's or what have you. But there's a lot of other things that are certainly picking up, maybe going. And these aren't all indoor examples. So some outdoors near businesses and getting coupons or attractions to get you into the stores. Those are certainly going to be coming about as time goes on. Driving, that's more of an outdoor classical example. Actually, once you're inside a business, you may be directed to coupons. So if you're in the men's department, you might get ads telling you different things that might be on sale in the men's department. So it's not just getting in the store, it's once you're in there, what kinds of things can location be used for to get you to move around and find things that you might be interested in. And then, of course, there's the classical navigation through a mall, or through an airport, what have you, and so on. Getting to sort of the vision technology side of things, some of the key drivers for indoor positioning. I think everybody thinks about LBS, iPhones, and Android phones, and so forth, but 911 is also a very important aspect for indoor positioning. I think, I'm trying to remember some 911 stats, but I think from about a year ago, I think there's roughly 250 million 911 calls in a given year. And of that, I think something like a third are actually done on wireless handsets today. And it's conjectured that maybe upwards of 50% or more are done indoors. So I think right now the mandate sort of takes positions sort of on average over the entire network, but there's some potential that the FCC will start to add mandates for indoor positioning, and so you have to prove that your technology starts to work indoors as well. So I think from a 911 perspective, 50-meter type accuracies would be sort of the key that you'd be looking for. Then there's indoor location. So we've heard mention of a few things like where am I indoors, location-sensitive search, and these numbers, I put tildes there. There are lots of conjectures as to what kind of accuracies you need for those types of things, but in general, you still want to get to some pretty decent accuracies. And then sort of the holy grail is when you get to indoor navigation, where you're doing high rate fixes, you really need highly accurate positions, and low powers can be key. Okay, so indoor beacon technology. I'm really grouping this as a very broad category of some sort of device that's installed indoors to facilitate positioning. Could be passive devices that, by passive I mean mobile to be, say, listening, or active, might be transmitting, for instance. And somehow observable on a mobile device. So the radio category, we've obviously heard talk about wireless LAN. There's other technologies, UWB, RFID, picocell. These are all indoor technologies that can help you in positioning. and who knows, maybe even optical laser. As far as the location technology options, proximity detection is one simple example. If you're talking about a short-range transmitter, simply detecting it gives you some good position information. And then there's the other techniques we've again heard about so far, like signal strength or fingerprinting type of algorithms. And then in the ranging category, angle of arrival, ranging, RTT, and so on. As far as the challenges of beacon technology, one of the big issues is cost. So public Wi-Fi is kind of highlighted in green because they're already out there free. One of the big penalties of many of the other beacon technologies proposed is cost. You have to deploy them everywhere indoors, and it costs money. And in many cases, there's a power implication as well, which I'll talk about in a moment. So, on the power front, there's some devices like RFID that do not require power, but other beacon technologies do. So, not only do you have to install them indoors, but sometimes you have to route power to them. And so, when you're talking about technologies where you're trying to get to meters or 5-meter levels of accuracy, it's easy to say, well, sure, let's just put all these transmitters all throughout these buildings, but it costs money. The other big issue is provisioning. So in order to facilitate accurate indoor positioning, you need to have an element of applications. And that means you're programming into the devices, their locations, so they can broadcast it to facilitate more autonomous positioning. Or you have to have some kind of an almanac, either in the device or in the network, that keeps track of the locations of these devices. So the key points, though, is these have to be very accurate. So many of the reverse positioning types of techniques used to sort of back figure where all these transmitters are may not work to accuracy levels needed for indoor positioning. And then I guess the last thing is on the mobile device side. Wi-Fi, Bluetooth are making their way into smartphones. Bluetooth's everywhere, but Wi-Fi's got a pretty high attach rate. But other types of beacon technology aren't there. And just adding a new transceiver to the phone costs money, and it's got to offer a lot of benefits for each of them getting in. So the bottom line, the biggest challenge overall adding all this up is accuracy. In order to meet the indoor accuracy needs, you have to have really practical beacon and mobile device cost constraints. Okay, on the femtocell side, femtos are now being pretty widely deployed to provide sort of wide wireless WAN coverage indoors, primarily in the home. So they're connected to the broadband internet, and they must have known positions to begin with to facilitate 911 call routing. So if you dial 911, the network needs to determine from that IP address exactly where that femtocell is and route your call to the right PSAP. And again, these things are short range, just like the proximity idea. That can suffice as the 911 position provided to the PSAP. So rather than a challenge, it's almost an easy opportunity to take advantage of that. In addition, there will probably be larger types of femtos called picos or microcells deployed like in larger buildings or enterprise areas to extend wireless WAN coverage indoors. And they may have longer range than 50 meters, but they can nevertheless be viewed as something to help the indoor position. They may not be your final position, but they may help to inspire other systems or be used as part of the fallback. Okay, on the sensor side, we've heard mention of a few of these types. Pressure sensors provide altitude. They're not in a lot of cell phones today, but we need to come up with some clever ways to take advantage. Certainly, there's like running apps and bicycling apps where you do care about your altitude. Altitude sensors are getting extremely accurate, so they could be a very, very valuable part for location, LBS as well as 911. Accelerometers, they're already in phones today. Almost any smartphone has a tilt sensor. They may not be quite as accurate as what we might need for navigation and positioning, but they're on a good trajectory. And gyroscopes are still a little bit too big, too expensive, and power hungry, but there's still a good roadmap there for them to start to make their way into cell phones as well. And similarly, magnetic field sensors are already showing up in instances. So some of the challenges, some of the MEM sensors are becoming quite prevalent in smartphones, but to facilitate sort of indoor types of navigation applications, we may need more accuracy. And really there's all these constraints of size, cost, and power, as well as the accuracy. They're definitely in the right trajectory, just to start to get there, but I don't know if we're quite there yet. There's definitely a lot of research in this area, so I didn't have a whole lot of slides on how dead reckoning works, but I think the algorithms are there. It's really just a question of the technology getting the sweet spot so that it can make it phones at high volume. Some of the challenges, of course, of sensors are just accuracy, bias, and drift, and how to calibrate for those. So these technology works really nicely if you know your position, but as time goes on, they drift. And then power consumption is going to be a big issue there. So I'd be remiss if I didn't mention other measurement sources. So GNSS and wireless WAN positioning certainly play a big role in outdoor location. But indoors, it's quite clear that it's not the answer, but it's certainly part of the answer. It can always help out if you're able to obtain a satellite or two, in addition to other indoor technologies, it can help out. So hybrid solution, I believe, some form of beacon technology will be key to indoor location. I'm not going to draw any conclusions. Wi-Fi is certainly high on the list for many of the reasons I discussed in terms of the challenges. But it's still yet to be seen what's going to really turn out to be the answer there. And really, when you get into some kind of navigation scenario, some combination of beacon technology and inertial sensors is going to be the answer. I think practical, when you talk about practical costs of beacon deployment and handset technology, it's probably not going to be accurate enough to stand on its own. You probably need sensors to combine with that for navigation. Similar sensors that alone won't work. They will help you out in position, they just help you out in your motion. And then other position technology will continue to help augment that position. But I think along some of the lines of some of the previous talks, managing power consumption across these technologies will be critical. So hybrid technology selection, as mentioned by others, you won't simply want to just use everything that you have and watch your battery drain in a matter of minutes. You really need to manage the energy per location fix, and sometimes turn off certain technologies that might help you, but you're meeting the needs of your application and the users, the type of application you're running. Maybe it can suffice to use a subset of those technologies. So in conclusion, new indoor technologies will be required to meet the accuracy and availability requirements for emerging indoor location apps, and possibly new mandates. Really, a combination of some kind of beacon technology and sensors will be key components of the indoor solution, as well as augmentation with other technologies. And really, for this to be deployed on a wide scale, as opposed to just in this particular mall or that particular university, it's got a practical deployment cost, both in the mobile devices as well as the network itself. And it's also got to be some technology, some mix or selection of technologies that can have reasonable power consumption, so that you can achieve some of the goals that Tim was mentioning earlier, kind of one charge per day. So LPS has already exploded. It's other devices for outdoor applications. There's no question that there's a market for highly available and accurate indoor location, and it will be significant value to location apps. Thank you.
You talked about sensors for other applications showing up in the phones for tilt and compass, and kind of implied that those were not quite at the level needed for indoor navigation. I'm just curious, how far of a leap do you think is required as a major technology change?
Yeah, that's a good question. I'm actually not a big expert on sensors, but certainly recognizing tilt changes can take a very low grade 3D accelerometer and do a very reasonable job there. Yeah, so I'm afraid I can't put numbers to it as to where we need to go. There's definitely technology out there today. There's 6 accelerometers that are extremely accurate. It's just a question of the cost point. It's all those factors that you can get it into a $500 phone perhaps, but to really make these sorts of things mass market, to take Verizon Navigator as an example, this is now what we thought would start out, these very high-end phones, and very quickly you'd see phones on the Verizon website showing voice, SMS, and BZ Nav. And so it's an app that made it down to the very lowest tiers of devices. And so you'd like indoor nav to be able to do the same thing. But yeah, you can't just put sensors in there for positioning. The key is to find a whole bunch of neat things that they can leverage on. And it's already happening. It's already happening. It's just a question of what accuracy levels will be required. And in many cases, you can use them to the extent, even if it's slightly less accurate than what you might need for meter level navigation, it'll support what it can support. So maybe it'll support 5 meters or 10 meters.
Any more questions?
When you're talking about hybrid, in military and commercial, there are different requirements, because in military, for example, they want to go to a city somewhere, they can have a chopper through sensors around. But when you go to commercial, it is what it is.
Exactly.
So how do you see the difference between the technologies?
Well, that's why when I see pitches about or academic topics on UWB positioning, for instance, where in a room like this you deploy 15 sensors, 4 sensors, and yeah, you can get centimeter precision, but who's going to deploy hundreds and hundreds of sensors per and that's the practical side of it. We work for a company and we sell hundreds of millions of chipsets a year, and we're not interested in sticking new hardware and new software on phones that only work in universities and 2 malls. So it's got to be something that's mass market. That's one of the big pluses of Wi-Fi. It's everywhere. You got to wait for when you go indoors, you need to have sub-meter positions for these access points. So driving around city streets may work outdoors, but it's not going to work indoors.
But for example, Bluetooth, for example, have you seen anybody use it in commercial application? In military application, I've seen people using Wi-Fi, Bluetooth, and everything. But in commercial, real commercial.
There's one company out there that's pitching that, and I believe, I think it's called Wireless Works, and they've instrumented like 1 or 2 university campuses with Bluetooth transmitters all over the place. And on the right side, it's in all the phones. All I have to do is load a new Bluetooth profile that's looking for these things that broadcast position or floor or address. Great, you get it for free. Problem is, again, it's the same thing. So the device costs, you have to buy these transmitters, you have to power them, you have to provision the position, and then you have to install them everywhere. So for it to be ubiquitous, it's not clear, especially with these unfunded, who's going to fund it, who's going to go to every apartment building in Manhattan and every business in Manhattan and deploy these. I don't think Verizon's going to do it. I don't think the FCC is going to do it. That's the problem. Nobody's going to do it. So that's the biggest challenge for indoor is the best approach, I think, is to take advantage of what's already there. Yes.
I think some people they don't recognize that. If you have everything inside the thing, that's not as important. You have to have an infrastructure of access points.
Yeah.
So that's the differentiation.
So unfortunately, there's nothing on my list of beacons that has its green on every count. So there's challenges. There are challenges. That's why indoor positioning is much harder than outdoor. Yes.
Do you have statistics of penetration of sensors in mobile phones?
Well, in smartphones, it's 100% probably.
Which sensors?
I don't think there's a smartphone that doesn't have a simple tilt sensor. But as you get into lower end phones, I don't think they're in much volume at all. So that's the main application, is just flipping your screen. Those are the simplest ones. As time goes on, there's image stabilization, for pictures, it's all kinds of gaming applications. There's lots of drivers, but it's really going to be the phones that support high-end cameras and games and things like that.
Could you know, for example, the penetration of Compass in mobile phones?
Compass I don't know so much about, but there's not too many applications other than navigation that would be tied to a compass. And really when you're driving,